All right, so there's this thing called approval testing, and it's really useful for testing legacy code. When I talk to people about unit testing, oftentimes they're like, I have this giant legacy code application, I don't know how to test it. Approval testing will help you out with that. It's a thing, I didn't make it up, somebody else did. You can see it's in a whole bunch of languages. The first time I used it was in Python when I took a Python class. It works really, really well there. So you think about traditional unit testing, and especially test-driven development, you start with what you know. So test-driven development, you know the correct answer. You're implementing some formula, so you're doing temperature conversion, and you know that 100 degrees Fahrenheit is equal to, 212 degrees Fahrenheit is equal to 100 degrees C, right? So you have a known input, known output, and you're verifying that the code actually produces the correct answer. Sometimes when you get legacy code, you have a big chunk of code and it has some inputs and it has some outputs and you don't really know what the heck it's doing. The example I used this on was written in German. There are a bunch of outputs and inputs and everything was named and I still had no idea. And they did a really great job of commenting on it, but didn't help me at all. So we don't know that the code actually produces the correct answer, but what we do know with the legacy code is they've been using this code for 20 years and it works. And the boss came and said, hey, let's add this tiny little feature. And you're like, that's great, but I got to refactor all this stuff and rearrange it in order to be able to add the feature. And so what you want to do is be able to refactor the code and rearrange stuff without breaking it, without causing its outputs to change. And so we're not exactly verifying that the output's correct. We don't even know that the output's correct, other than that they're using the system and it works. We simply just want to make sure that we make changes to the code that we're testing and the outputs don't change. And there's this thing called Hiram's Law that basically says anything that anybody can depend on your code, like if it has some weird quirky behavior, somebody's probably depending on that at some point if you have enough users. There's an XKCD comic about pressing the space bar and heater control and stuff. You can go look it up. I thought about throwing it here, but I don't have a lot of time. So basically the way approval testing works, you write the test, you run the test captures some output into a file, and then you mark it as approved. So that's the first time you run the test. You just say, hey, whatever this code outputs, that's approved because we want to make changes to it. And we don't want to change the code we're testing. And then you go make your changes. And as a regression test, so every time you make a change to whatever code you're testing, you do your refactoring, you run the test, and the test captures the output again, and it compares it to the approved version that was stored in a text file. And if it matches, the test passes, everybody's happy. That means your outputs haven't changed. If there's no match, the test fails, and the output that the code generated gets stored in a file called, whatever the name of the test is, .actual. So you have a .approved and .actual in their text files, and you run through some text diff tool and it says, hey, line 33, this thing changed. And then you go decide if you want to approve that change or not. If you approve it, the test fails, and then you go throw away your changes and go try again. If you approve it, then every test that runs from now on is looking at the new approved value. This is the library they put together. Really simple, it's one VI. There's some sub VIs under there. But basically, you pass in the test data as a string. It looks at the file and it handles all the file stuff. It looks at what the previous approved version was, says, do they match? Great. Outputs a passed or failed, a Boolean, and a failure message. So you can use this with any unit testing tool, Karai, JKI VI tester, doesn't matter. You just drop a pass if and you wire in the Boolean. And if it supports messages, you get a little message that tells you, explains how to go do the approval thing. On disk, so this is an example. I've got a test case. This is VI tester, say a test case, that's the class file. Go set up a teardown. And then I've got, in this case, 4 tests. They all have a .approved file. That's basically the name of the test, .approved. You open up, it's a text file. And you can see one failed. So the top one there failed, and it's got an actual file. So if I wanted to see why it failed, I would just do a text diff of those 2 files, look at them and say, hey, this line changed. Did I expect that, right? Sometimes you change something, you expect the output to change. If it changes the way you expected, great. To prove it, you just delete the existing approved file, rename the other one, and everything's good. And you store those approved files in your source code control, you ignore the actual files, and everybody's happy. But somebody's gonna say, well, okay, that's great, that works on text, but my output's not text. That's actually really easy. You do something called a printer, and the simplest thing is you just flatten it to JSON. So if you have a complex cluster class, or you have a VI that has a bunch of outputs you want to verify, you just bundle them all together, flatten it. It works really well if you've got legacy code that's got giant clusters. You don't have to figure out what each value in the cluster is supposed to be and wire up a whole bunch of asserts there. You just drop one approval test, flatten it to JSON, and that's it. And JSON makes the diffing really easy too, especially if you pretty print it, which I highly recommend because otherwise life sucks. Dealing with difficult data, sometimes you might have something, in this case, we've got a cluster of data and it's got an acquisition time. Well, every time you run the VI that produces that data, assume that's like a VI that we're testing, right? Every time it runs, you get a different acquire time. Well, that's constantly gonna change. Simple solution, you use regex or JSON set item or something similar to replace the data that changes with some placeholder. So here I just flatten it to JSON. I look in the JSON, find the acquire time and set to date. That's it. Great use cases, legacy code, God clusters, God classes, iterating through lots of various inputs. So you can run in a for loop and just concatenate all the string outputs, write them to a file. That's it, you write one assert. It's easy. Serial and TCP comms, you can do loopbacks and you can capture what's being written or read on the serial port. You can get it on VIPM, and I wrote a blog post about it. That's it.
A special thanks goes out to Kevin Chyrie, Quentin Q. Aldridge, Mark Balla, and Jeff DeBoer for their help in filming. And of course, this GDevCon NA 2023 wouldn't be possible without all of our sponsors. Thanks.